Just one. All right. Connor's coming, though. Okay, good deal. So, what we've got going on now is we've got equivalent fractions. With equivalent fractions, we actually probably will understand these pretty easily and pretty quickly, is my goal. Okay? Last time we saw that fractions could be written as decimals and decimals could be written as fractions. Today, we're going to let you write the factors of each number. All right, not the prime factors, but just the factors. So, like for 8, it would be 1, 2, 4, and 8. Okay, what about 10, Adlin Ron? Let's start with you. Very good, Adlin. All right, Landon. I haven't heard from Landon today. Landon, what about number 3? All right, 1, 2, 4, 8, and 16. Number 20, what about you, Amelia Giebert? What goes with 2? All right, the only one I hear you forgot was the 4. All right, 1, 2, 4, 5, 10, and 20. All right, and Colby Voss, what about 30? Nice job, sir. That one, usually we forget one. Well done. So you guys did that pretty well. Now, we're going to do the problem of the day. Good job, Lily. I'm so proud of you. All right. To write equivalent fractions, we are going to use again and again and again and again the thing that I call a fancy one. 7 over 7. What number is that? 1, right? So what happens if I multiply 6 times 1? What do I get, Ian? 6 times 1 is 6. So what's another way? Is this also 6? No, this isn't 6, what I'm going to put in this box. That's not 6. Yeah, because what is 6 divided by 1? It is 6. Now, earlier, I'm going to circle it. Ian told me that 6 times 1 is 6. Do you guys all agree with that? Yeah. So what happens if I do this? I multiply by 7 over 7. Is 7 over 7 just a fancy 1? Well, what's 6 times 7? 42. What's 7 times 1? Hold it. Earlier you guys said 6 times 1 is 6. Here I took 6 on the bottom over 1 times 7 over 7, which is 1. Why did I get 42 over 7? Or is that actually 6? What is 42 divided by 7, Landon? Is 6. So, is it really the same thing? 42 over 7 is 6, right? So if you multiply by a fancy 1, it stays that same number. That's kind of what we're going to be dealing with today. Equivalent fractions in simplest form. Fractions that represent the same value are equivalent fractions. So, 1/2, 2/4, 4/8 are equivalent fractions because they're all the same as what, Lily? They're all 1/2. Can you give me another fraction that would be 1/2, Lily? Ooh, 5/10. Oh, and you know how she got there? She said, I'm going to take this times 5 over 5. Is 5 over 5 just a fancy 1? Yeah. So 5 times 1 is 5. 2 times 5 is 10. 5/10. All right. Give me another fraction, Kenley, that is equal to 1/2? 3/6. All right, 3/6. Oh, if I take 1/2 times 3/3, Liam, does that make 3/6? Yeah. All right, Liam, give me another one. Give me a fraction that is equal to 1/2, Liam. 20/40? All right. Oh, my gracious. I'm sorry about the horrible handwriting. So, Liam, how did you get to 20/40? What did you multiply by? 20 times 2 to get to 40. Did you also take the 1 times 20? Yep. So to change a fraction to give equivalent fractions, you multiply by a fancy 1, which is 20/20, or it could be 3/3, or it could be 5/5. It could be 7,000/7,000, couldn't it? Yep. All right. So let's move on then. All right. I'll move all my stuff here. Oh, I didn't want that. I wanted this. All right. And then back to the pen. Oh, 1/2. Whoa. Now, with this picture, I really do like how they look. Is 1/2, you can kind of see it here, compared to 1/4 and 1/4, 2/4, and 4/8. Do they cover the same amount of area, Olivia Valroy? Yeah, they do. So that does show that they are equal. Okay? So 1/2, 2/4, and 1/8 is equal. And what we just did, we could also do the same thing for 3/6. We could also do the same thing for 20/40. All of those. Okay? So we need to find two equivalent fractions. We're going to be able to do many things, and there's many, many, many of these. Okay? So we're going to start with 10/12. And there's two ways we can find equivalent fractions. You can either multiply or divide by a fancy 1. So I'm going to talk to Liam. I want an equivalent fraction for 10/12. What fancy 1 are you going to be using to multiply and get this answer? 2. So we would put 2/2. Is that a fancy 1, Liam? All right. And then what is my equivalent fraction to 10/12? 20/24. Do you agree with him, Lucas? Now, let's say I didn't like to work with big numbers, Lucas. All right, if I didn't like to work with big numbers, what could I divide? What fancy 1 could I divide by to get a smaller fraction? Ooh, we could divide by 2/2. And what is the equivalent fraction that we get, Lucas? 5/6. So I have a question then for Miss Eve. These two fractions that I circled, 5/6 and 20/24, are they equivalent? Yeah, because they all represent the same thing. Just 1 second. Yes, you do. All right. So very good, very good. So let's go ahead and see how they show it, and then we'll move on from there. So to get two equivalent fractions, 10/12 is 1. Okay. We could have 15/18. Oh man, that one was a complicated one. They multiplied by 1.5. All right. Or we could have 5/6. Both of those are equivalent fractions because do you see they cover the same amount of space? This one, if we took it times 1.5 over 1.5, which I don't know why they chose to use that one, that'll make 15/18. And if we divide this one by 2, like Lucas did, we get to 5/6. All right? So there are equivalent fractions. Now, 4/6. Let's do one more, then I'm going to ask you a question. When we look at 4/6, there's two different things we can do, right, Kendall? We can either multiply by a fancy 1, or we can divide by a fancy 1, right? Do you agree, Kendall? Yeah? All right. So, Kendall, do you want to do a multiplying or a dividing? Which way do you want to find an equivalent fraction? Dividing? Okay, what number can we divide? What fancy one can we divide by? 2. Now, I have a question for you, Ian. Could she have picked 3 over 3? Would that have worked? Well, does 4 divide by 3? No. So it wouldn't have worked real easy. We could have done it. So what is 4 divided by 2, Kendall? And what is 6 divided by 2? When you're dividing, it's important to pick a number that both numbers are divisible by. So now, Ian, as we go up here, what's a fancy 1 that we could multiply by to get an equivalent fraction, Ian? All right, Ian, did you come up with one? What's a fancy one you're thinking of in your mind, Ian? Any fancy one? Oh, when we're dividing, that is important. Is that important, Ian, when we're multiplying? When we're multiplying, it's not as important. So when we're dividing, it is important. When we're multiplying, it's not important. So you can pick any fancy one you want in the world, Ian. What one do you pick? Any fancy one in the world, Ian. 8 over 8? All right. So 8 times 4 is 32. 6 times 8 is 48. All right. That gives me an equivalent fraction. That gives me an equivalent fraction. All right. What was something else that I could have used? Kendall, what's another thing that I could have used? I'll come back to you. I could have used 2 over 2. All right. Now, 8 and 12. Oh, all 3 of the circled numbers are the same as 4/6. Are all 3 of the circled numbers, Lily Miniman? Are they the same as each other? Yeah, they are. Good job. Good job. So, these fancy ones make all the difference in the world. All right. 4/6, 8/12, 2/3. They chose some simple ones. All right. I need you to put your heads down right now, please. Now, when you put your heads down, how are you feeling about making equivalent fractions? 5 is I got it really, really good. 1 is I'm not real sure, Mr. Palm. Go ahead. Give Mrs. Leifer a number, and then she'll let me know. All right. It sounds like Mrs. Leifer said okay, so we can put our hands down and our heads up. All right. So now we get to start to play games with these. All right, Landon? Or Addie? When we start to play games, we're trying to figure out what did they do to change this. So, Landon, now I'm looking at it like this. I'm going to pretend this is a fraction here. Oh my gracious, that's horrible. Now, what did they multiply 5 by to get to 20, Landon? 4. Okay. Now, if I'm going to multiply by a fancy 1, what has to be my number on top too, Landon? So, what number goes in the box, Landon? 12. Oh, do you see how that works? Let's see how Landon did. All right. So, times 4 to get 20. We got to do the same thing on the top. So, it was times a fancy 1, right, Ian? Do you see that? All right. All right. So, 3/5 is equivalent to 12/20. All right. Oh, and they do cover the same amount of area, don't they, Olivia? All right. Is everybody okay? All right. So now we come here and I go to Addie. Addie, I'm coming to you. All right. Then next I'll have to go to someone else. Now I'm going to pretend like it's here. So how did I change 4? What did I do to 4 to get to 80, Addie? Oh, I multiplied by 20. So how am I going to get what's in the box here, Addie? Oh, 20 over 20 is a fancy one, isn't it, Addie? Yeah, so they're making equivalent fractions. So what is the bottom number here on my big fraction? 100. Well done, well done. Oh, let's double check to make sure Mr. Palm didn't make a mistake. He's been known to do that. All right, very good. That looks very nice. All right, I like it. And do you see this one that is 4/5 covers up the same space that is 80 20th or 80 100ths? All right, now let's look at this one. All right, I haven't come to Mr. Stenzel in quite a while. All right, Mr. Stenzel, what did I do to get from 9 to 27? So what do I do to the top then, Mr. Stenzel? And what is the number that goes in the box? Ian, how do you think he did? Good. All right. So 3/9 and 9/27 cover the same area. All right, let's try this one out, everybody in the room. So I want to know the number that goes under 40. Now think, what? Good. Raise a hand when you've got it. So think, what did they multiply the top by, and what do we have to multiply the bottom by? Okay, give time. Don't give out the answer. All right, Liam, what did they do to the top to get to 40, Liam? Multiply by 20. What do we do to the bottom then, Liam? And what do we get for the box, Liam? He said 80. All right, 80 is our answer. 80 over 40. Oh, hey, what other number that we're really familiar with are 2/4 and 40/80? They're both equivalent to, what's the simplest form of this? 1 over 2, 1/2. All right. Now, every fraction has one equivalent fraction that is the simplest form. Now, I know you know simplest form because I know how good Mrs. Letcher does with it. All right, a fraction is in simplest form when the greatest common factor of the numerator and the denominator is 1. That means they don't have any numbers that are in common except 1. So, example 3 shows two methods for writing a fraction in simplest form. So, write each fraction in its simplest form. When we're doing simplest form, we're going to be dividing, right, Kenley? So, what number could I divide the top and the bottom both by to try to get it to simplest form, Kenley? 4. All right, I like 4. Now, why is it so important, Lucas, that I put 4 over 4 and not just one single 4? Because it's 1. Very good, Lucas. Thank you. 20 divided by 4 is 5. 48 divided by 4 is 12. Now, can I simplify 5/12 anymore, Kenley, or are we good? Good. Now, there's another way we could have got to this, right, Olivia Valroy? 20 over 48. Now, let's say I said you got to divide by something, Olivia Valroy, but you can't use 4. Is there something else we could have used? Besides, oh, I'm sorry, go ahead. Oh, 2 over 2. Now, let's say, Olivia, I said 2 over 2. Well, that gets me 10 over 24. Okay. Now, Olivia, as we look at that, is 10 over 24 in simplest form? No. What would I need to do again, Olivia? 2 over 2. And when she does that by 2 over 2, she gets down to 5/12, right, Seamus? Now, what is 2 times 2? 4, right, guys? So does it matter if we take 2 small steps like Olivia showed us, or 1 big step like Kinley showed us? Does that matter, Amelia? No. It's whatever you feel comfortable with. So if you say, oh, I can divide by 2, and you think, oh, I can divide by 2 again, you can still get the same answer, right? Or if you divide by 4 and do it in 1 step, you get the same answer. All right? So, good job, ladies. Now, method 2, if we have really big numbers, we can use prime factorization. All right? Prime factorization, I will show you the way, but I think it's easier just to divide by the fancy ones. All right, Alan? All right. So, we're going to write all of these as prime factors. So, 2 times 2 times 5, 2 times 2 times 2 times 2 times 3. Why did they cross these off, Alan? Why did they cross those off, Alan? There's 2 of them in a row. So then I get 5 on the top, and 2 times 2 times 3 is 12, right? So some people do like to write them out like this and do the crossing off and then see what's left. Otherwise, you're very welcome to just do it the way we've been doing it. So, 7/10. All right. What can we divide by to simplify this fraction, Amelia Giebert? You can't. There's no common denominators. The only one is 1. And does that change anything if we divide by 1? Nope. So, it's already in simplest form. All right, Eve, is there anything you see we can divide this one by to get a simpler, or the simplest form? She said 4. All right. 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. Can we go any simpler, or are we done? Done. Nice job. Okay. What's that? But does that change anything? It'd still be 3 over 4. All right. So we use prime factorization. Oh, we still got the 2's that we can get rid of. All right. What about this one? Brody Stellhorn. What can we divide by to put this into simplest form, Brody? Quiet, folks. Let him think. All right, Brody, what can we do to put it in simplest form, buddy? Can you translate for me, Mrs. Leifer? Okay. Would he be right if he said it's in simplest form, everybody? Good job, Brody. All right. All right. Ian, give me an equivalent fraction for 4/10. 2 over what, Ian? 4 over 2? Okay, you want to use 2 over 2. Okay, I got it. Are we multiplying or dividing? Will both get you an answer? Divide by 2 over 2. Okay. Divide by 2 over 2. So 2/5. Oh, my gracious. 2/5. You did very well. What about this one, Lily Miniman? Give me an equivalent fraction. 1/2. All right. Would she be right? Yes. What about this one, Kendall? What do I need to do? What goes in that box, Kendall? She says 6. How did she figure out it was 6 that goes there, Lucas? All right. Very good. What about this bottom box? Oh, I have not called on Blayton. Blayton, go ahead. What goes in this box, Blayton? The box that the blue dots by. What? Times 5? All right. It is times 5. What is 15 times 5, Blayton? Is it 75? Yeah, it is. It's 75, I'm pretty sure. Oh. All right. Write each fraction in simplest form. All right. Now, my question to you, how did they get to 1/2? What did they do, Amelia? How did they get to 1/2? They divided by what, Amelia? What, Amelia? Thank you. 4/4. Remember, just like you're at home, you got to yell at them like you yell at Lucas, all right? All right. Alan, they get to 1/7. What did they do? 7/7. All right, because that's a fancy one. All right. Ooh, somebody with a hand up. Which two are equivalent? Pick one of the nice, quiet girls. What did Addie say? I'm sorry. Okay. It would be letter B. All right, Colby, if you can manage to be quiet while I go through this, you can answer the next one. Which ones are equivalent here to 3/8? Hey, he is, because if, we take it times 3/3, we get 9/24. 4/4 is 12/32. All right, now we're going to stop recording now. I think you guys are ready.